So in the last video, we found the first and second order critical values, and then we built this giant table with all the test values, and then we actually applied the first and second derivative tests within that table. Not first and second derivative, sorry. First test, first derivative test, and the concavity test to figure out whether we had inflection points and local extrema. So now we're just in the home stretch. We have to do 7, 8, and 9. So 7 is that we're going to find asymptotes. So that's part 7. So find asymptotes. Now there's 3 kinds of asymptotes. There's horizontal, vertical, and slant or oblique. So I'll just make a note: vertical, horizontal, and slant. Okay. All right, so let's begin with the vertical asymptotes. We've known how to find those since, Algebra 2. And actually, we kind of already found them. They're where the function cannot be equal to, or the denominators cannot be equal to 0. So x squared minus 1 equals 0, x squared equals 1, x equals plus or minus 1, or if you like, you could factor it. Right? So this will be the vertical asymptotes right here. Right? It's where the denominator of a function like this cannot be 0. All right. So, because this is a rational function. Then horizontal asymptotes, there isn't going to be one, and that's because the numerator has a higher degree than the denominator. So, sorry, this will be vertical. I'll just put that right here. Horizontal, none. Right? Now, why is that? Well, we learned about that back in chapter 2, and we also learned about it in precalc. The degree of the numerator is greater than the degree of the denominator. If that's the case, we're not going to have a horizontal asymptote, so I'm not going to bother with it. Of course, if the degree of the denominator is less than the degree of numerator, the degree of the numerator is less than the degree of the denominator, then it would be 0. If they have equal degrees, then it's a ratio of the coefficients. So we can just say C section 2 point, I believe it was 2.5, but I'm going to double check that real quick. Yes, it was. It was section 2.5. Now, if you want to do it analytically, technically what you have to do, let me just write the function again real quickly. It was 10x cubed over x squared minus 1. If you want to prove this, like really prove it analytically, because this is just a little memorization trick we have for ourselves, you would multiply by 1 over x squared over 1 over x squared, right? And then it'll become 10x over 1 minus 1 over x squared, and yada, yada, yada. We learned how to do this in section 2.5. All right, then that leads us to the slant asymptote. And you might be thinking, oh, please let there be no slant asymptote. No such luck. There is a slant asymptote. Let me just try to fit it in over here. There's a slant asymptote because the degree of the numerator is 1 greater than the degree of the denominator. So that would mean that I have a slant asymptote at, I'm just going to pick a different color here. You put the numerator inside the division box, and you put the outside, so x squared plus 0x minus 1 out here, and then you multiply, so, or to me, you divide. So what times x squared would get me 10x cubed? That would be 10x. So this is plus 0x squared plus 0x plus 0. So over above the 0x, I would write 10x. And that would get me 10x cubed plus 0x squared, because 10 times 0 is 0, minus 10x. These would, I would subtract the whole thing, so 10 take away 10 is gone, 0 take away 0 is gone, 0 take away at negative 10 would be 10x plus 0. X squared cannot go into 10x, so we're done. So this right here, y equals that, is the slant asymptote. Actually, let me just write this. There we go. Right. I'm using the powers of long division, polynomial long division. So 10x is, or y equals 10x is our slant asymptote. Now notice these have equations, right? So you can't just write plus or minus 1. That's not a vertical asymptote. A vertical asymptote is a vertical line. So it has to be x equals, right? Like that. And then a horizontal or slant asymptotes, these have to be equations. So either one of them, if this existed, it would be y equals. If slant asymptotes exist, it's y equals. 10x alone is not the slant asymptote. Y equals 10x is the slant asymptote. So you have to write an equation. So note, asymptotes must be an equation. Must be equations. So it's either x equals some constant, y equals some constant. This is vertical ones, this is horizontal ones. Or for slant ones, it'll be y equals some ax plus b, right? Some equation of a slanted diagonal line. So vertical line, horizontal line, slanted line. So that's just an aside. All right, and we're in the home stretch. Step 8, we need the intercepts. All right, there's two kinds of intercepts. There's x-intercepts and there's y-intercepts. And it doesn't really matter which one we find, so I'll find the x-intercept first. So the x-intercept would be, let's think, where the function is equal to 0. So that would mean f of x equals 0. So that would mean 10x cubed over x squared minus 1 equals 0. Well, if that's going to happen, it's got to be the numerator that's going to be 0, because if the denominator equals 0, we've got problems. And that would mean x equals 0. So the x-intercept is 0, 0. And you might be thinking, hey, that's a y-intercept as well. Yes, it is, right? Because that's the origin, right? The origin is both an x and a y-intercept. So this is both an x-intercept and a y-intercept. Now, what about a y-intercept? Well, to do a y-intercept, they're actually easier. You let x equal 0. So you find f of 0, which is 10 times 0 squared, or 0 cubed, excuse me, over 0 squared, take away 1. Sorry, my cube got weird there, which in fact would be 0. So this one worked out to be the same. There was only one x and y-intercept, and it was the origin. However, it's possible that you have an x-intercept, it could even be the origin, and then you'll have a couple different y-intercepts, or vice versa, have a couple x-intercepts and only one y-intercept, or 3 of each, or well, actually you can't have 3 of each. I lied. So the y-intercept, there can only be one, right? So this one there can only be one, this one there can be lots of them. Right? And why can there be only one? Well, it's on the y-axis. The y-axis is a vertical line, so you can't have more than one y-intercept, otherwise it wouldn't be a function in x. So for y-intercepts, there can be only one, ever, right? For x-intercepts, there can be more than one, but there just isn't in this particular case. So that's a little note. Right? So x-intercepts, because they're along the x-axis, you can have lots of them. But y-intercepts, in order to keep it a function, can only be one. So it's just a little note to remind yourselves about some, basically the vertical line test that you learned about in pre-calc.